Hear you on the
Okay.
bridge.
Okay, cool. Yeah, let me share the screen. There's a little bit echo there. Okay, sorry, just. Can you see my screen now?
No.
Okay, just one sec. How about now?
Yeah, we can see the screen now, Lihua. Yep.
Okay. Wait. Sorry, there's a really strong echo coming back my way. Okay. Okay. Anyhow, let's get started, right? So, as Dave said, the SONiC community is really thriving with your participation, right? And so I'll start with actually sharing the 2025 community update. Some of the things that as you are participating in the community, you might already know, but many of the things, because we are a very kind of active and very large community, so hopefully that you catch something interesting as well, right? So, and then I go to the deep dive on the SONiC for the AI backend, which is probably the hot topic for everyone in the world right now, right? So, okay, so the community. One thing that I want to bring up, right, is that we got two new board members from Arista and Nextop AI. Right, so they are actively participating and contributing into the SONiC ecosystem, right? And meanwhile, the contributing orgs are growing to 60, right? So the logos are getting smaller and smaller in the limited space, but that's exactly very exciting, and there's even more to come in the pipeline. Right? So we're really a thriving community, and the 2025-05 release, right, was actually the most recent release. It was delivered on time on May 50, right? So we really enhanced quite a bit of the enterprise support to meet the community on the desire of having SONiC go beyond the cloud and into the enterprise. Right. That being said, we didn't really forget about our root in the cloud, so we added for high performance network in the to meet the AI demands with SRv6, which I'll get to later, and then the BGP scale enhancements to deal with devices that have much higher radix. Right. As operators, we are always very passionate about diagnostic features, right? Right. So high frequency telemetries, local fault and remote fault detection for the optical stuff, right? And the handling of link flap, etc., right? And more optical level stuff of prefec and post-fac analysis, right? Those kind of things, right? We are aggressively pushing SONiC into the smart switch era together with the DPU, right? And so we support multiple kind of DPUs through Dash API, right? And but in the ecosystem, we're trying to kind of handle the upgrade as a different entity, right? And then more fundamental things, we are upgrading FR and upgrade, always catching up with the latest Linux kernel, and they've been released, right, to move things forward, to make things more reliable and secure. So they're really big kudos to companies like Arista, Broadcom, Celestica, Cisco, Dell, EdgeCore, Marvell, Micas, NTT, NVIDIA, etc. Right? So there's a lot of stuff there, right? And it's there's many features. We had 65 proposed feature in this release, and 31 got completed, and some of them are going to basically go in. It's meant for multiple release feature, so it's going to come later. Yeah. So the 2025-11, which is the one that's going to come in a few months, and the community is we're very actively working on it. Right. So you can find more details on the GitHub. right? And many of the features are already pretty much in progress with people actively review the HLD and contributed the PRs, right? So it's really seriously starting, right? And we're going to have a Debian 13, right? So that we're catching up with the latest Debian, right? And the fifth is going to be on the 140-3 for the new feature, MaxSec, right? To meet these days, more and more governments care more about compliance, right? And this local adaptive routing and switching to meet the AI demands, right? So again, kudos to all the contributing companies. Okay, and in addition to that, right, we are setting up a SONiC interoperability test lab at UNH, right? So UNH, University of New Hampshire, is actually a very active place for all the Ethernet layer 1 interop testing, and we work with them closely to set up this lab, right? So the SONiC community already signed a MOU with them on how we are going to set it up, right? This test lab is going to be open to everyone in the community, right? For people who are needing of a testing facility or interested in contributing a test. This is where I think you're going to see a lot of actions, right? You can find more information online as well on the SONiC interop testbed. As we kind of broaden the community, right? We are trying to set up the mentorship program so that we can encourage participation from the college students, right? And more to enjoy open source and look into cloud networking as their first career, right? And also have a place to really kind of participate in the community and work with people, right? And there's a very fixed mentorship program. We actually started small in this year to so that we can figure out everything right. And there's many interesting projects being proposed by the mentors from different companies, and I got a very active participation from the universities. Right, so I won't read through the interesting projects there. It's all mentored by the senior engineers in various companies. Right, so we've passed the phase of recruiting the mentees, right, and selected mentees, onboarded them, and the projects are well in progress by now. Right, so we're gonna kind of conclude the internship in November, and then we're going to look at starting next year for more opportunities for the community. And the community are expanding with new projects, right? There's new ideas, new proposals, right? So I'll highlight a few new working groups, right? The first one is a virtual data plane working group organized by Google, right? To bring the Alpine virtual switch into the community so everybody can leverage that, right? To prototype new ideas, set up test environments, right? And then there's a Google Microsoft collaboration on optical circuit switching, right? So basically, the optical circuit switching is a way of doing circuit switching, right? And that's being heavily explored in the context of AI or low latency network, low latency, low power, low cost network, right? So it makes things very efficient there, right? And the small layer 1 working group, which is at the Ethernet layer 1 for features and specs from hardware and software, led by Microsoft, NVIDIA, right? And many interesting stuff like co-packaged optics, LPO, right? Macro LED work are happening there, right? So I will encourage everybody who's interested there to take a look. This is a very interesting and moving very, very, very fast in this days of hardware technology. Okay, so with that, right, I'm going to deep dive. Cannot really go in depth into all the topics, just way too many. But we selected just one topic on the AI side to deep dive a little bit, so you can get a taste of what's happening in the SONiC community. right? So this is probably a familiar diagram that is basically SONiC in powering Azure and a lot of many Azure clouds in at scale, right? At the various layer of the network. And in the AI backend, right, things are a little bit different, right? And the bar is actually even higher than the cloud, right? So there's a long-lasting and large flow of training data, right? And there's a large burst of data sent synchronously, right? So that makes congestion control very interesting, right? Workload placement to be very challenging, right? And the demand, the long training time, and the thing that the AI training workload hit most is a network failure, cause them to go back to checkpoint and redo the training, right? So they demand a very reliable network, right? So and the retries of failed jobs really is going to increase the cost, right? So that requires us to have very efficient traffic management, monitoring, and visibility. And if we have any issue, we need to be able to diagnose it very well with traffic with high burst, right? And eventually, it's conceptually we need to go to lossless traffic with very low latency to support the AI workload, right? So and the classic Rocky V2 has a low entropy for ECMP, so and that makes it not super ideal there. Right? So traffic engineering technologies for the AI backend is necessary, right? So summarize again. So because of the need of traffic load balancing, the network are moving quickly into source routing to allow the workload to have much better control of the traffic placement, right? And not only for efficiency but also for failure handling, right? And to deal with traffic burstness, new technology is being developed with hardware vendors and SONiC community together on this thing called packet trimming, which I'm going to go in depth a little bit, right? And then to support the performance diagnostics, right? We have to enable very high frequency telemetry. The classic SMP counter polling is just not going to meet the demand of AI workload. Right, so source routing with SRv6 it's actually pretty straightforward. Right, so basically in SRv6 there's this standard called macroseed. Right, it's a way of using the IPv6 header a little bit differently. Right, that encodes a path. Right, so and in the network, every switch or every element is assigned a macroseed ID. Right, so it requires a certain pattern of macroseed assignment. But essentially, that allow as long as the NIC knows the macroseed along the path, right, they can basically very accurately control the exact hop it's going through to reach its destination. Right, so that's the essence of the adoption there. Classically, SRv6 is a wide area service provider function, right? But the SONiC community collectively figure out a very interesting way of leveraging this the capability to use that for the AI backend. Right, so in the SONiC stack, right? So you look at it, basically the SDN controller, right, or the whoever control the source parts can talk with config DB, right, and the config DB will set the seed and the locator to the through the FR stack of BGP config D, and eventually it lands on the hardware switch, right, and then the forwarding can happen based on the packet header. Right, so this is a classic Yuan behavior, right? That is being that is well defined in the SRv6 standard. Okay. In packet trimming, right? So this is the way of notifying the host about the congestion, right? And because if you the classic way of TCP, right, depends on either a packet loss or retransmit to notify the sender or the receiver about packet loss, right? But both are considered way too slow for AI applications, right? So we would like the packet congestion to be notified to the sender a lot faster, so that the sender or the receiver can react much faster, right? So if you look at on the left side, you see a original Ethernet packet with MAC header, IP header, and data, right? And you will send the input port. And when you go to the egress port, you hit a congestion, right? And what do we do there? Normally you would drop it, right? But what's being done with packet trimming is that we actually move to a different queue that is empty, right? But we change the DHCP value and we cut the majority of the payload, right? So that it becomes much smaller packet, right? And with this much smaller packet, it is much more likely to go through the network. And this packet, because it does not have enough data, right, it cannot really serve the purpose of being used. But it is a much faster mechanism to notify the receiver about congestion. Right? And just extending there, right? And we are also trying to let end host know where exactly the packet got trimmed, right? So that you can separate whether you're dealing with uplink congestion or downlink congestion, right? So the actual algorithm of dealing with the congestion is a separate topic, but at the bare minimum, you need a switch to tell you where the link is congested, right? So I probably won't go through this diagram in much detail, but you look at it, then with the header information, right, and the TC to DHCP mapping change, right, we can actually be very, very accurately tell the receiver of where the packet trimming happened. Right? So this is packet trimming, and on high frequency telemetry, right? This is a diagram of the system, right? But basically, the essence of it is that we had integrated into the Linux kernel with a netlink actor message, right? So the kernel we are building the IPFix record so that we're event trigger and it can go to the order of milliseconds, right? For all the counters, right? And those counters can be stored or be streamed through open telemetry actors to send it out to the open telemetry collector. Right. This is a very fine piece of software engineering work to move a lot of counter collection capability into the switch ASIC and the Linux kernel stack, right? So that the things can be done a lot faster instead of polling. Right. Even the classic implementation in SONiC of streaming telemetry was not fast enough to reach the millisecond level collection, right? And this is how we kind of enable that. Okay, so just a few examples. There's more, and probably so I'm only sharing that a few to kind of whet your appetite, right? And Akshay and the team, and this SONiC event is going to kind of go through a lot more interesting stuff, right? So as always, I'm inviting everyone to actively contributing to SONiC, right? With the hardware, with the platform, right? With the test tooling, right? And you can find all the information, right, about source code, wiki, right, and mailing list, etc., where the community gathers, right? And I hope you have a very enjoyable event in India. Thank you very much.